2244, April 29, 2025. Right now marks 1020 hours of progress in the global horror simulation. Currently, the console output for printing a custom matrix from a custom 3D math utility helper script has been finished, seemingly. This seems to check out mathematically now over the course of creating this and creating the dot product and the normalizer and the cross calculator for the product of vectors. It was sort of confusing and what all that was necessary for, but looking at the math here, it seems to check out. Now what this does is the set lookout left-handed, it basically attempts to create a left-handed, well, a view matrix, which is basically the view for the camera in a left-handed perspective scene. So like DirectX is a 3D render, and so it uses a left-handed coordinate system, and basically this seems to check out because the values inputted here, what's being outputted makes sense, and setting the identity matrix also makes sense at this point because that sort of creates defaults for everything. So for example, the forward vector 1 on the Z makes sense because just as a demonstration here, this uses DirectX Math, whereas the this scene here uses DirectX Math, whereas the project that was just being looked at uses a custom 3D math library just for matrices and vector 3s. But basically positive Z goes forward into the scene in a left-handed perspective render or coordinate system, and negative Z goes further in, and the positive right is to the right and negative is to the left on the X. Well, positive X is on the right, negative X is on the left, and up positive on the Y is up, and negative on the Y is down. So you have the Z being positive goes forward in the left-handed perspective, and the math for the going back to the matrix output console, this seems to add up. Well, this custom function for calculating this seems to add up because this line right here at the top, this is believed to be the right vector, and the one in the middle is believed to be the up vector. Yeah, because that Y in the middle, the Y value is 1. Right here for forward, the 1 is to the right. So yeah, that is the right vector because the X is on the 1, which makes sense because X on 1 is going to the right. And for the one at the bottom, this, so that one is right, that one is up, this one is forward. Yes, Z going positive is forward, and also because looking at this, the I was set to -3 for the Z, and over here in the translation axis, +3 comes out as the positive Z value. And yeah, this seems to make sense mathematically. Now there could be some random error here which is not being picked up at the moment, but the intention for tomorrow is to just take this simple 3D math library and try to create a custom 3D camera completely from scratch using it. Just simple logic, and see if that checks out in DirectX 11 without using the DirectX Math. And that is the true way to verify that this is all being calculated correctly. Now there are separate routines for calculating the this is the look at, the other one is the FOV left-handed. There was a tutorial that showed how to do that, as well as it had its own method for generating left-handed, but that was being done in the main loop, and it was sort of messy and hard to understand. But going through the math manually, just by reading up on how it works, this seems to check out really well. So yeah, that is the intention for tomorrow, is to actually test this by trying to make a camera, and apparently a camera in a 3D program is merely just a matrix 4x4. So there's a view matrix and a projection matrix, and that seems to be all there is, just two 4x4 matrices. There could be things for calculating or updating position, but this should work out, assuming the 3D objects have their matrices set identity, so that this has its default set, and they are updated, and then after their positions are updated, updating the matrix every frame after that. That should check out, and after updating the matrix, while updating the matrix, assuming, this is currently row major, believed to be row major, and then converting, transposing that, which means converting it to column major for the shaders, because the HLSL shaders, GPUs do column major faster, so this needs to be transposed before sending that off to the shaders. And so that should check out. That should seemingly be all the steps to do this, but like was mentioned, the only way to really verify that is to see if a 3D camera such as the one shown here can be created using it, and if it can, then that would be a alternative to the DirectX Math, or a simpler alternative, because DirectX Math does a lot of stuff, but that simple math library could be a basis for learning about other things such as quaternions and other useful 3D math logic.